ladies and gentlemen. Today is August 28th. Today we are looking at some symmetry of graphs. I have to start out just kind of by saying I think that symmetry is kind of an archaic sort of thing. A long time ago, before we had graphing calculators, symmetry is really useful for helping us graph equations. But because we have graphing calculators, we can really get to the answer much more quickly and learn what we need to learn. So we're going to, basically today, the goal is to show you symmetry and what it means, but we're going to show that symmetry using our calculators and using the tables on our calculators and recognizing some things about points when we have symmetry. And so we have three types of symmetry we're starting with here: with a y-axis symmetry, symmetry with respect to the y-axis, symmetry with respect to the x-axis, and symmetry with respect to the origin. And hopefully you see some pictures there on page 17 of what that looks like. And then also we are going to do a little bit of algebraic testing, algebraic proof. And so that's at the bottom. How it turns out to be, it's quite easy. How to prove that something is symmetric with respect to the y-axis is that box at the bottom of the page. You see that box that says algebraic test for symmetry at the bottom there on page 17? We're going to be looking at that box in just a little bit. So to get started here, example 1. Example 1, complete the graph given the symmetry. Complete the graph given the symmetry. Oh man, here, here. This is going to be a letter B. I forgot to change it. Sorry. We'll do that one first, and then origin symmetry.
So we're doing A.
Yeah, we're going to do A first. Yeah. All right. So we want to complete the left half of the graph if we have the given symmetry. And so I'm going to start with that y-axis symmetry on letter A. Sorry. Wait, we're going to start over here with this one. Yeah, okay. Oh, this is kind of an interesting graph. This is actually a cosine function. We'll learn about these second semester. Now, what does it mean to have symmetry with respect to the y-axis? What do you think?
Bless you.
Wow. God bless you. Across the y-axis. Very good. So if you were to take this graph and then just sort of flip it right over that y-axis, that would be symmetry with respect to the y-axis. Or if you were to put a mirror on the y-axis, then you would see the other side of the graph reflected there. So you have some points, like this point here is 0, 5. Does he go anywhere, or does he sort of stay where he is? He stays right there. Now this point, this is actually pi over 2, 0. That's kind of interesting, huh? This is pi, which means half of that would be pi over 2. All right. So this point right here, pi over 2, 0, he's going to jump over the y-axis, or rather get reflected over the y-axis. Where is he going to land? Very good. Right here at negative pi over 2, 0. Okay, so I can sort of connect those two things. And so here's another point right here. God bless you. This point is pi 5. And again, he's going to get reflected across the y-axis. So where's he going to land? Negative pi 5. What do you notice about these? Oh, that is just terrible. Okay, sort of better. What do you notice about these ordered pairs that we've got going on here? What, you're changing the sign on what? Oh, okay. So if I have a point like right here, that's maybe x, y, I don't know what it is necessarily, but if I wanted to reflect it over the y-axis, what would the new point be? Negative x, the opposite of our xy. And that is also how we prove that something has y-axis symmetry. You'll notice we have opposite x's, but the same y. If you're trying to prove something is symmetric with respect to the y-axis, what we do is we actually use an opposite x in the equation and see how it works out. So that's kind of interesting. All right, letter B here. We have a lovely little curve. This is a sine curve. Again, we'll do that second semester. Symmetry with respect to the origin is a little more complicated. So first of all, I want to point out that this graph starts at 0, 0. In order for a function to have symmetry with respect to the origin, it either has to pass through 0, 0, it must pass through the origin, or it might be undefined at the origin. But usually it's going to pass through the origin. If it goes through 0, 1, it's not going to be symmetric with respect to the origin. Okay? So when we look at origin symmetry, I have a point right here. And I'm going to approximate that point. I'm going to say it's like 1.5. 1.54. And if that point to be reflected through the origin, it's kind of weird. What happens is it goes straight to the origin and then pops out the same distance straight out the origin. Where does it end up then? Negative 1.5, negative 4. Very good. And so I can sort of try and reflect that graph there. Let's see. Here's another point. I'm going to say this point right here. I'm going to say that point, I don't know what that is, like 4.5. All right. 4.5, negative 4. And again, if this is going to be reflected through the origin, I had to take a whole course on this in college. It goes straight through the origin and pops out straight on the other side, the same distance away. And where does it end up? Yeah, negative 4.5. What? Positive 4. Okay, kind of interesting. All right. Kind of interesting. So what's happening with these ordered pairs? If I have any xy here, like here's a point xy, I don't know what it is, but it's xy. If it gets reflected through the origin and it pops out on the other side, what's its new point? Negative x, negative y. The opposite of what we started with and the opposite of what we started with, okay? So origin symmetry, you'll notice, has lots of opposites. Opposite x's and opposite y's. And that is how we're going to be proving that algebraically. Kind of interesting. Okay. So drawing, not so hard. These are complicated graphs, just so you know. It's nothing quite this hard in the homework. All right, so now we're going to sort of put all this together with our calculators and everything. So here we go. These are the directions that you're going to see in your book. I don't want you to do these directions. You're going to do what we do here in our notes, okay? So use algebraic tests to test for symmetry through both axes and the origin. These directions actually want you to do all 3 algebraic tests. I'm going to say, oh my God, why? So what we're going to do is we're going to use our calculators. We're going to narrow down the list, and then we're going to use the test on the one that we think is right. Okay? So we're more going to figure out what kind of symmetry we've got and then do that test. Okay, kind of weird. So let's see what I mean. On letter A here, we have x minus y squared is equal to 1. I want to be able to graph this in my calculator. So what do I need to do?
Move that x over.
Move the x over. So get y by itself. So yeah, we need to move our x over. So I have negative y squared equals negative x plus 1. And then what? Divide by the negative 1 and then square root. So I have y squared equals positive x minus 1. And then we're going to take the square root. What do you have to remember when you take the square root? Plus or minus. So when you have to take a square root, you have to remember plus or minus. Which means we're actually getting two equations to represent this function. The positive square root of x minus 1 and the negative square root of x minus 1. Whoops, 1, not y. So you need to put in two equations in your calculator. So right now, you take out your calculators. And then in y1 and y2, you need to put in both of these equations. So in y1, we have radical x minus 1, and then in y2, whoops, we have negative square root of x minus 1. So whatever calculator you've got, go ahead and graph those. Mm-hmm. So, all right, what does this look like? Sideways parabola, yeah. When x is being squared, it's an up or down parabola. When y is being squared, it's a left and right parabola. It's called a hyperbola. So we get this shape here. I'm going to make a sketch. Anytime you use your calculator, a sketch is totally worth it. Really easy sketch here. And I want to go ahead and try some values. You'll notice, I don't know, maybe 5. I want to use trace and type in a 5 and hit enter. And I see that I have the point 5, 2. Now you'll notice up here it says y1. That's because it's on the equation for y1. If you arrow down or up, it doesn't matter. It'll switch to the other equation. And I want to type in the 5 again and see that on that second equation, y2, we get 5, negative 2. What do you notice about those ordered pairs? They have, what do they have? They have the same x, but different y's. Opposite y's, the same x. Okay, you see that? They have the same x's, but they have opposite y's. Okay. Is this symmetry with respect to the y-axis, x-axis, or origin? X-axis. That's what we think, right? That makes sense. That's being reflected across the x-axis. Okay. So this is symmetry with respect to the x-axis. What we want to do is we want to do the algebra for it. So on page 17. On page 17, it says the algebraic test for symmetry, and it's the number 1. The graph of an equation is symmetric with respect to the x-axis if replacing y with negative y yields an equivalent equation. So it says replace y with negative y and see what happens. Replace y with the opposite of y, which is exactly what's happening with these ordered pairs. We have a positive y and we have the opposite. Okay, so what I'm going to do is I'm going to go to my original equation And instead of a y, what am I going to replace that y with? Yeah, so use parentheses very carefully and square it. And what happens? Do we do the negative times negative?
Not yet.
No, yeah, not yet. We got to do the exponent first. What is negative y? Quantity squared. Y squared. Everything else remains unchanged. And so this is exactly the same as what we started with. Therefore, symmetric with respect to x-axis. Symmetric with respect to the x-axis. If you replace y with negative y and you get the equivalent equation to what you started with, that's it. That's the proof. Kind of weird. Let's look at this one, letter B. X cubed minus 4x equals 0. Oh, I'm sorry. That shouldn't be 0. It should be a y. Gotta have y equals there. All right, so again, this is an equation that I could graph on my calculator. So let's go ahead and make a little graph. Does this need 2 equations or is it just the one? Yeah, just this one. So go ahead and graph x cubed minus 4x. Ooh, interesting. What does that look like? Origin, yeah, definitely origin symmetry. Let's get some data points maybe. What do you think is a good number to test? 2?
-1.
-1. Okay, sure. Let's try -1. I'm going to plug in a -1. So -1 gives me a 3. So what's another number I can test for x then?
1.
+1. Yeah, we want to use some opposites. So I want to type in a +1 and see what I get. +1 gives me a -3 output. So you'll notice we have opposite x's and opposite y values. And that, again, is how we prove this algebraically. So let's, again, look at our box on page 17. On page 17. The graphing equation is symmetric with respect to the origin if replacing x with negative x, this is number 3 in the box, x with negative x and y with negative y yields an equivalent equation. So I want to replace x with negative x and y with negative y in my equation. Now let's see what happens. So instead of x, what am I going to use? Negative x, and I'm going to cube that. Oh, here's another x. What am I going to replace that with? Negative x. Good. And here I have a y. What am I going to replace that with? Negative y. Good. So let's just do some cleanup here. What is negative x times negative x times negative x? Negative x cubed. What happens with the -4 times negative x? Plus 4x is equal to negative y. Now this doesn't quite look like what I started. I need to get the y by itself. What should I do? Divide everything by -1. And what do we get? X cubed minus 4x equals y. And that is exactly the same as what we started with. Therefore, symmetry with respect to the origin. Symmetry with respect to the origin. Okay, do you have questions for me? Yes, questions.
So what would you do if it doesn't?
If it doesn't line up, then you could say neither.
So you say like no symmetry.
No symmetry. Yeah. Yeah. No very special symmetry. Yeah. So yeah, that is an option. Secret option D, none of these. Okay? Good question. All right, ladies and gentlemen. You have class practice 20. 20 minutes.